used in order to admit pods. That's used when the kubelet restarts. That's used just to produce the pod status, if I remember correctly. Is that correct, Yuju?
Yeah, so I think David's referring to that we do write some labels on containers and use that to reconstruct part of the pod spec.
You mean status?
Yeah.
Yeah, this would be the same thing. So the status in this case would be what is the current allocation, which is there are two parts to it. One is the request and the other is limits. And limits is currently stored in the C group, although the API does not allow you to query that. It can be modified. However, there is nothing we do about the request. We only have the sum, and we base it on what the spec tells it. That's fine today because we don't expect that to be mutable, but in this KEP, the proposal is to make that mutable. So thinking more about it, extending it to keep the requests and limits along with the other information can help it be the source of truth to regenerate the resources allocated that's in the status, proposed in the status today.
Right. What I'm trying to figure out is, so today the current state is that when the kubelet restarts and it reconnects to it'll wait until it reconnects to the API server. It'll get the pods that are running on it, and then it'll perform admission on those. And so the key piece that we're missing, right, is that we want to not reject pods that were running before simply because a different pod, say, had requested a resource increase, right? That's the goal.
Yes, that change we'll have to make in the pod add.
So you're saying that we would now have to, when we perform admission, look both at this internal state piece that we've saved to disk, as well as the pod spec.
We can continue to admit, yes, we'll have to look at both because we generate whether it fails node capacity, it comes from that. So from the internal state, we would know what the current state is. So that would be the source of truth. And if the current state does not match up with the desired state, then we know that this is a pod that was in the process of being resized, or a resize was desired on it. And we can very quickly tell whether it's admissible, whether the resize is admissible or not. The pod itself is admissible. So that change would be there in the handle pod add.
Well, no, we also actually perform admission on pods, right? So this isn't just about setting the status field. This is about making sure that if, for example, one pod has requested an increase to the entire size of the node and gets admitted first, that we don't actually perform that resize until all the other pods that we're running have also been admitted, right?
Yeah, if the resize results in exceeding the capacity that's available, then that particular pod we would admit it, but we would say that the pod has failed resize. So the desired state would still show. The change would be in when we call the pod lifecycle, I believe, in the predicates. We pass the pods. We set the desired sum. The current, if a different value of current resources allocated is found, we use that instead of using the desired. So that would be a change to the admission control logic.
Okay. And how do we ensure that all the pods that we're running actually come back before we try and perform any resizes? What's to prevent, for example, a pod gets admitted with its previous requests, and then we handle the resize upward of that pod's requests before other pods that were running on the node get admitted?
So there are two cases to consider here. One is the kubelet restarted and nothing has changed on the API server side. So no new resizes has come. And in that case, if we were exceeding capacity, then we would see, in both cases, it would be applicable. When a pod has been admitted, we atomically write the current allocation. So a new pod comes in, then its requests and the resources allocated would be similar, would be the same. So we write that. And if a pod is in the process of being resized, and then the kubelet restarts, we see the difference between what's current allocation is and the desired is, and then we can queue that to, we can admit that with the current allocated values and work towards resize. The third case is when a pod resize was requested while kubelet was offline, and the same logic applies there as well. So
I mean, I guess the scenario I'm thinking of is, let's say there's 2 pods running on the node. Each one is requests half of the node's resources that are allocatable.
yes.
One pod is incredibly high priority and has all the special markers to make it so. And the other pod has requested an increase in its resources, but it hasn't been granted. And then the kubelet restarts, and the first pod we get is the lower priority pod. What's to prevent that pod from being admitted and then having its resize applied before the super important one gets there, I guess, is my question.
So okay. There is, the pod updates come in incrementally, and the first one comes in. So here is the thing: when the first one, the higher priority, are we talking about the case where preemption is in place or not?
Actually, Yuju, do we have that sources ready thing to denote that we've gotten all pods from the API server? So as long as we actually in the kubelet track whether we've received all the pods from the master. So as long as, were you saying that we would handle the resizes during admission, or would this be part of the update process?
Oh, it would be part of the update. Admission would only say whether, would determine whether a resize was in progress based on the current source of truth stored on the local node locally. And second, it would it would determine whether the resize is failed node capacity or was in progress based on so let me think about this case a little bit more.
Well, I think we should be able to work around it in theory.
Once we get all the pods, if we apply the do the resize determination, that'll work. But my thought was, as the pods come in, we can determine whether it's a resize in progress, and second, we can determine whether resize failed node capacity. Now, as we are adding,
right, there is trying to update that pod condition at that point, which would be quite hard because we don't have all the information yet.
We do have the timestamp in the status. So if we store at what timestamp, then we can determine. We don't have to until all the pods, especially if there is we received all pods, if we can determine that all the pods that were there before have been received, then we can definitely do this. The resize process itself won't start after all the pods have been handled. So I would think the implementation would put it in a queue, and the queue would trigger the resize queue, and the queue would trigger working on the pods resize after all the pods have been received.
Okay, I think this works in theory. I'm curious what other people's thoughts are on the idea of checkpointing resources and then using them during admission. It's definitely a pattern that the kubelet does not do today. And I know checkpointing has also been somewhat of a topic on which people have different opinions.
Why do you need a checkpoint?
Because the problem is that there's when someone has requested a resource change, and that's now the pod spec, but we don't want the kubelet to act on that. So the kubelet has some internal state of what is actually admitted, right? And so now we're trying to figure out how to store the kubelet's desired state of what it's trying to reconcile requests or resources towards. So that if it restarts, that we don't get bizarre behavior where all of a sudden all resource updates are implicitly applied because the kubelet restarts, it gets a pod from the API server. That pod has the newer resource requests and limits and such. And so we don't want, for example, the scenario I described was where a low priority pod gets admitted with its very high new resource requests and kicks off, say, kubeproxy or something else, right? Or I guess not kubeproxy, but some, yeah. So we need some way to store the desired state of the pod according to the kubelet. And the alternative is that we would have to put it in the pod spec and do a sub-resource update or something.
Yeah.
But Vinay has said that he doesn't prefer that.
It just makes it a little bit more, I would say, heavy-handed I don't know if that's a good term to use here for one resource update. Now we have resources, which is the desired. We have resources allocated, spec.resources allocated, which what the kubelet is working towards, which kubelet has agreed to. And we have the status resources allocated, which is the actual current state, which is generated. So doesn't it seem like a little heavy-handed? I'm okay either ways. I just feel if we can do this without having to modify the spec, it's cleaner, more lightweight implementation. We can certainly do this with the spec and using a sub-resource so that only kubelet updates it.
I don't have enough knowledge in the area to tell you what are the exact pros and cons, but I guess I don't know if you. Hey, this is Bobby.
Yeah.
Yeah. So I haven't really thought enough about this, but also checkpointing, especially not checkpointing, recovery oftentimes is not that easy on restarts. So that's also not a very easy solution. Sometimes it might be easier to just update resources on the API server and rely on the API server. And in a way, actually, that's how Kubernetes works. Everything that is persisted is in the API server. And it's probably better to follow that model for everything else as well. But of course, as I said, I haven't really thought carefully about this. This is just the first time that I'm hearing about this, so I might be wrong.
Okay, it's fine. I think let's just review it over the coming week and think about the two approaches and see which one makes sense. I'm okay with both approaches. I just was leaning towards the local checkpointing. I also need to think through a few sub cases here and make sure that the state that was before a restart is exactly where it's going to be after restart. I'm going to work through a few examples here over the week, and hopefully we can converge on this soon. But thanks for the input.
Let's see if we can get Derek's opinion on this as well, I think.
Yeah.
Thanks. One quick comment on that. So even if you didn't go with the checkpointing behavior, that still wouldn't preclude some sort of event or conditions being set on the status, right? So that you could tell when or if a resize operation began, or does that make sense?
We can. So pod conditions have timestamp, but the idea is to not rely on anything that's stored in the status.
Yeah, I'm not saying rely on that to do some checkpoint operation. I'm just saying I think it would still be useful from an informational perspective to have that sort of condition.
Yeah, I think so too.
Okay, so you weren't saying get rid of the condition. You're just saying get rid of the assumption or the expectation that you can checkpoint or do some sort of status operation with that condition. Is that correct?
Yeah, we have to do the checkpointing to get the source of truth on where kubelet was with regards to resizing before the restart occurred. The pod condition, I guess most people, David and all, have not been in favor of it. I only feel it's necessary. It's useful, not necessary, but useful to have it so that the cluster resources are better utilized. So, for example, if VPA sees that the pod condition, if without the pod condition, the VPA will have to wait like 3 seconds, 5 seconds, 30 seconds, and then say, oh yeah, it's been too long. I'm going to evict this pod. Or if it sees the pod condition set, then it can very quickly say, okay, my policy allows this. This can tolerate a reschedule, so I'm going to evict it, and the controller will generate a new one, and we'll put on a new node, which has capacity. So that in my mind, it's useful to have, and it's. But people have differing opinions about it, and it's something that we can always add on. It doesn't have to be there on the first implementation. Similar to preemption. These two, preemption we've decided we'll add on if needed later.
Okay, I think we've spent enough time on this. We can talk offline and make sure we work through all the corner cases.
Yeah, let's do that.
Cool. Thanks.
Thank you. And David and Bobby. So let's move to the next topic. And so the Hatcher and the Brandon, you two propose to talk about the image description and secret. Can you start from here?
Yeah. All right. Thank you. So Harsha and I have been working on this image decryption KEP, but before I get to that, let me just give some background on this. So we've been working on something called container image encryption for the past year. And the idea here is, you will be able to build a container as well as encrypt the data and the layers within the container. And so when you upload an image to the registry, it will say encrypted. And when you download it and run in the runtime, it will perform the decryption. So the idea here is that we have an encrypted container image that we want to decrypt on the runtime, which is the relevance for the KEP. So this is work that we've done. We've implemented this in Container D. This is merged into Container D right now. It's targeted for version 1.3. We also have ongoing work in the other runtimes as well as having this part of the OCI image spec. But the KEP that we have open is really talking about how do we provide a facility for Kubernetes to use this feature. And the main idea for this KEP is really similar to image pull secrets, where passing credentials to pull an image from a registry. We are using the similar facility to pass keys to perform the decryption of the images. So Harshal, do you want to talk a bit more about the KEP? You want to take over the screen share?
Yeah, sure. I'll just share my screen. I think you'll have to stop sharing. It says,
okay.
Yeah. Yep. Are you able to see my screen?
Yes.
Yep. Okay. Cool. So as Brandon mentioned, right, we had just recently merged the container encryption and decryption container D. So the way we see Kubernetes playing a role into is that during the runtime, we need to decrypt these images on the worker node before they get merged. And in order to decrypt them, we need to provide the keys required for the decryption to succeed. And looking at that, while we're trying to see how it can fit in Kubernetes, Kubernetes already has a infrastructure for storing secrets. So we kind of came up with a secret which can be used to store these necessary keys to decrypt the images. And this secret is modeled after the image pool secret, and we call it image decrypt secrets. The reason of its model after image pool secret is unlike other type of regular secrets, this secret which holds a private key needs to be consumed by the container D or any runtime while pulling the image, and should not be mounted on a pod. So here's a enhancement proposal that we submitted with the Kubernetes, and I already talked about what the main motivation about behind this KEP. The main goals that we are trying to achieve here is like have a secret which can have a key, and these secrets can be used, like in a regular pod YAML or maybe deployment YAML, and we also have integrated them in service accounts. What it doesn't cover this secret is that it has no role to play in the encrypting images. So we see Kubernetes playing a role in decrypting images, but these secrets or this proposal does not deal with being able to encrypt the images. So here are some of the user stories that we see. Like, for example, if you're a cluster user and you want to be able to create a file that create a secret that holds a private key, and you should be able to have the encrypted container images in a public registry that you should be able to decrypt with this secret, and so on. So we propose an API definition for image decrypt secret, as well as, so going over the detail, this has a strong resemblance to the way the image pool secrets have been designed. So it mimics the behavior of that. We couldn't use that because the image pool secret is tightly coupled with its usage of being able to provide credentials for pulling container images which are behind the username password. So we needed a place where these secrets can be stored in a dedicated place. So we have a reference implementation in this KEP that I'm referring to. This, by the way, I think this KEP number is 1066, in case anyone wants to go. Yeah, and then the way some of the examples that I would like to go here, here's like, suppose if you want to create a secret, so you'll probably go something like kubelet, kubectl create secret, image decrypt secret, and the secret name. And we have the demo in the links here, which Brandon has posted in meeting notes. So you'll first create a secret, and once a secret is created, you should be able to attach it to the pod. Now, when you don't attach it to the pod, but you attach it to the container, because unlike the image pool secret, every single image here could be encrypted with its own key. So we like to have image decrypt secret associated with the image. Then this is where we describe how we can use a service account, and with the service account, you should be able to use the secret just like you would any other secret. Then, yeah, this goes in detail of the API image handler. We added the DC params. The DC params essentially represent the keys required to decrypt the image, and you can see here in the second line, the auth config is the one what existing image pool secret uses. So right now, the essentially relationship with there's a strong requirement of having the image pool policies always. We know this is less than ideal. Yeah, ideally, we should not be depending on image pool policy. But if you're, let's say, if you have an image pool policy always, and if you are downloading a new image on a worker node, then the keys are required for you to decrypt the image. And even if the image is found in cache, you still need a keys to use the image. But if the user sets the image pool policy to if not present or never, So in case of if not present, the keys are still required, because when the new image is coming, containerd has to decrypt it. But if it's not, then containerd is going to if its image is already found in containerd cache, then the keys are not required. And if the image pool policy is never, so then new image case is not applicable, but the cached image case, the keys are not required. And as I mentioned, this is far from ideal, but this is right now inconsistent with the way image pool secret is designed and implemented. We were talking to Derek on the KEP, where he made a comment, and it seems like there has to be a generic solution to address this issue with both these secrets, like image pool secret and image decrypt secrets. So where the user setting a image policy should not affect the behavior. But just for the sake of consistency, we are keeping it that way, and we can probably address in another feature request. Similarly, there was another interesting comment made where this secret should not be mountable inside a pod, and it's a very, very valid point. But again, the solution has to be both for both type of secrets, not just the secrets that we are proposing. So there's a diagram that I like to open here. All right. So this gives a general idea how the secrets are consumed. So when you have when you get a request to create a pod, you retrieve a reference to the decrypt keys, and then when a kubelet sends a request to pull image, it sends a decrypt keys as well, and then same keys are passed to the containerd, and if the image exists, it checks the authorization. There is nothing changing. There's a recommendation on a KEP to check have the authorization check here as well, so that way the issue I talked about, users setting the image pool policy, can be addressed. But as I mentioned, we should be doing this for all the secrets, all the secrets as in image pool secret and image decrypt secrets. Going back to our doc. All right. We consider an alternative, is there any way to use Kubernetes with encrypted images? Yes, there is. We wrote a plugin for containerd, wherein containerd was smart enough to see if the image is encrypted, it will go and talk to your choice of key server or like a vault or something and fetch the keys and decrypt it. But in that kind of scenario, Kubernetes, we don't leverage the Kubernetes existing infrastructure for handling secrets, and then customers or users will have to handle the secret management on their own. So using Kubernetes, we can use Kubernetes, and especially secrets, we can make that experience of using encrypted images simpler. I talk about graduation criteria. I'm not sure whether we should be going over this in this call. It's essentially things that we can do given the time and in a beta, and there is a already implemented version there. So if you have any questions, I'll be happy to, me and Brandon will be happy to answer.
And there's the Patrick have a question related to the authorization.
Yeah, and so the way you described the image authorization, since it's happening on the node, that doesn't prevent someone with access to the node from being able to read that container. So are you just saying that once it's decrypted, it's unprotected and that's okay? That's the goal?
Yes. Yes. You go ahead, Brandon. Sorry.
Yeah, no, I was just going to say something similar. The current assumption of the threat model is that the node and containerd or whatever runtime is being run is locked down in terms of the content store as well as the runtime.
Actually, even Patrick, that one I just want to follow up. Even today, we have that similar problem. I mean, that's why earlier they are mentioned that image pool policy. So like just for example, there's the one node, they have the two container. One is the level, and another one it is asked for always and with the description secret, and then this like the container pool policy with the level could be benefit because that the image already at least I think from the earlier their explanation, I haven't read the type detail, but that's kind of implied.
Okay. I guess my feedback here is like, if we're doing a check on a node against a cached image, it seems like if there was an admission controller, you could basically fail faster if the user wasn't authorized, rather than waiting for it to get scheduled to a node and then failing the container start there. Like, I think it'd be more deterministic if you failed up front rather than after it was scheduled to a node.
Yeah, but the problem there is it's a container D who knows whether the image is cached or not. So we need to go all the way to container D and see if the image is found in container D's cache.
I guess what I'm saying is that I don't think it matters if it's cached if you do the authorization check beforehand.
Yeah.
Oh, okay.
So there's kind of two things here. One of it, I think, is that we didn't want to do a image pool as well during the admission phase. We would have to kind of pull out the image pool secrets as well. But I think the other point that we were discussing is that in the future we have received use cases for to be able to use hardware security modules or keys that are in the host unwrapped by TPM or something like that. So in that case, the decryption would and authorization would have to be performed on the node itself.
Okay.
Yeah, and the admission control does not have access to the descriptors where the wrap keys are there, right? So we don't pull the images in admission control to be able to do that.
Okay.
I mean, the images are pulled on the worker node, and during the pull process, we go layer by layer, and in annotations, we store the wrap keys and we try to unwrap them. So that logic has to be moved in admission controller, but admission controller pulling images directly in admission controller, I'm not sure whether.
Okay. I thought you could do it from the manifest alone. So, okay, thanks for clarifying that.
Yeah.
Any more question, comment on this one?
One question about this.
Introduce yourself.
Oh.
This is Nantou.
Oh, this is Lantau. One question about this. So is there a quick way to verify whether a decryption key can work given a cache for image? Because you said that if there's already a cached image, we want to verify whether we can use it, right? So do we need to fully pull the image, then we know whether the decryption works or not, or there is a way to know that faster instead of pulling the whole image?
Should you want to take this, or should I?
Yeah, I can take this. So the way it works is, Container D is pulling the images. Before pulling the images, you get a descriptors, and in descriptors we have annotations, and so the first time the image is getting pulled, it just pulls the blobs and try to decrypt it. The next time when you try to use the same image, if you're trying to provision a pod, what happens is the same pull request goes to Container D, but Container D finds the image in its cache, but you still have access to descriptor. So we just try to unwrap the key, and if you are able to unwrap it, we don't really fetch the blob again, and we just send the same block. We just send a success back. Your question about is there any way to detect earlier? So the very fact that the act of like downloading the descriptor and trying to unwrap key will basically fail. So I'm not sure that I answered your question. Think of it this way: like you're trying to pull an image, and while pulling the image, you get that the blob of the layer, and while trying to decrypt it, it's going to fail at that point. For the first time.
So I think we didn't have time to go through a lot of details, but how the implementation of the encryption works is that the blob is encrypted by a session symmetric key, and the symmetric key is being wrapped. And so what we do for the check authorization is we are unwrapping that symmetric key, but not actually performing the decryption itself.
Oh, okay.
Yeah, so that's a pretty quick operation.
I see.
I think we don't have much time, but before we move to next topic, I want to talk about what's your target for the, and I think everyone maybe have a lot of idea about the implementation detail, but it is wallet. I think nobody have question. This is the wallet request and the wallet feature, and we do want to integrate with Kubernetes in a better way. So there's no question. So then maybe let's just talk about what's your target.
We are hoping to target 1.16 because the changes in containerd are already there, and the changes for supporting CRI are almost there, and so we have to raise a PR for it. Even the Creo support is in our it's with us. We just have to raise a PR for it. So we think 1.16 should be fine. But I think the enhancement freeze for it it's the month end for it, right?
I really doubt you can get in 1.16 since today is the first time we talk, and because to get API in, that's really time consuming. So, and enough talk about implementation detail after we settle down all the API, because the API unit goes to the SIG architect API reviewer committee for that one. So even like the look at your API is relatively straightforward, but still I think there's a lot of time consuming. So I really doubt, and in practical, I think we can try to target 1.17, and we are assigned to like the even API reviewer from the SIG Node to help you to work together with the SIG architecture, because so then maybe can speed up the process, but still I think the 1.17 is the more reasonable timeline.
Yeah,
Not a problem. That sounds good. I just have one question. So since I'm still sharing the screen, this issue that I'm sharing, the add image to the 1066, this gets merged first, and then the PR gets up for discussion. Or when you said that we need to talk to API reviewers, we are also talking about this document as well. I mean, does the PR in the enhancement also?
Yes. You talk about the cap.
Yeah.
Yes, we could, from the node representative, we could talk about, because this cap actually include both API and also the implementation. So we could try to get the cap in, but still we need to have like the largely consensus on the API and also implementation. Right? So we will try, but I don't think we can get done before 1.16. Yeah.
Not a problem. Then I'll update the cap with the 1.17. Right now it just says 1.16, so I'll update it.
Sure. Thanks.
Yep. Thank you.
Let's move to next topic. And next one actually is what I proposed, and I also invited Bobby from the SIG scheduler. Maybe you want to talk like
sure.
the issue? Yeah, we have.
All right, so let me tell you a little bit of the background. So we used to have a concept called critical pod annotation. Critical pod annotation existed at some point in the past because we didn't have any notion of priority for pods. So when nodes were running out of resources, we didn't want to evict more important pods or critical pods. So this annotation was added to pods so that kubelet knows which one of these pods is critical and which one is not and can be evicted. In 1.13, and of course after we had priority, and priority gave us a way to identify which pods are critical, we didn't need this annotation anymore, so this annotation got deprecated. And recently we tried to completely remove it from our code base, but we ran into an issue, and it's for actually static pods. The way that the static pods work is that we create these pods on a node, and then an object, a pod object for these static pods is created. This object is called mirror pod. This object is created afterwards, basically after the actual pod is created on a node. This mirror pod is created on the API server. The static pods can have priority as well. The problem is that priority is like a DNS, kind of like a name server thing. We have a notion of the name of the priority, which is called priority class, and then the priority is resolved to its integer value at admission time. Admission happens when the pod object is created. So now that the mirror pod is created, the priority of these static pods is resolved to the integer value, and then we know which one of them is critical and which one is not. Criticality works only with the value. So if any value higher than a certain number, which is now, I guess, 2 billion, is considered critical. The problem is that at the time that the actual pod, not the mirror pod object, when the actual pod is created on the node, kubelet does not see the value because the value is not resolved. The value is later resolved at admission time of the object. So the value is nil or basically empty, and it's considered in 0, and the pod is not considered critical. So there is a chance, and we have actually seen it in production, that the pod gets rejected because kubelet or the node does not have enough resources. We need to change the mechanism that basically static pod priorities are resolved. One possible solution is that kubelet resolves the priority to the integer value for these static pods at the time that they are created. And then, of course, the same resolution happens later when the mirror pod is created by the API server. But we need to know the priority at the time that the static pod is created on the node side, so that the node does not reject the critical ones if it is out of resources. Resolving the priority is relatively simple. It's just a query to get the objects from the API server and find. Basically, the object is identified by the priority class name. You pass the priority class name and get the value and find what the actual priority is. So it's a relatively simple.
No, that's the implementation. Implementation at complexity. So then, which means the Kubernetes cannot admit. In these cases, we introduce another dependency on API server, and the Kubernetes cannot admit any other pods until resolve the static pod, the priority here. So definitely, it is the even bigger product impact here.
So. Yes, I see what you're saying. But why can't it admit any other pod?
Yeah, I think it could, but the problem is that we do serial admission. So once, like today, we go pod by pod. We say either rubber stamp, you're good, or reject.
Yeah, sure. I mean, given that the static pods are probably rare, I think it should be okay if you spend a few milliseconds resolving the priority.
First thing is not real. Depend on the SIG. We at least from the SIG node standpoint, we don't want to support the static pod from day one. We just couldn't totally get rid of that one. It's just because a lot of production depend on this one, even GKE. And I know many people depend on this one. So even there's the many self-host of cluster effort being carried on by many SIGs, but they didn't really make progress. So the SIG node still have to carry on this one. And static pod, but most people using the static pod actually is the quite critical pods. And the static pod, the worst part is the static pod. There's no any controller or scheduler can help it. If it's static pod by design, if you think about it, it is required to run pod on the node, which have that one. So because there's no such controller, there's no such controller to management name, and cannot reschedule to any different nodes. It's done like any other pod. But the problem it is. So what I would rather, if we have the common priority class, if we have to cannot totally get rid of the static pod support, I would rather like we have a great policy and default the static pod always have the inherent highest priority just by default. make everything so simple. It's just okay. Once you want you put
basically,
any file based.
Consider all static pods as critical, no matter what priority they have.
High is the priority. So the people and abuse the static pod is their problem, because this is basically a follow our originally policy for static pod, because we really don't want you using static pod, but for the most critical pod, you have no way to bootstrap those pods. It's just using static pod.
One quick question: is it possible in the kubelet admission to distinguish between a static pod versus a regular pod?
Yeah.
Okay, so in that case, yes.
Yeah.
In that case, yes. I think that solution makes sense.
I've been looking into some kind of more generic problems with mirror pods, of just like, if an admission controller rejects the mirror pod, that doesn't really make sense. And there's like, sort of the deeper I go, the more I see controllers that should just ignore mirror pods or always accept them or various things.
They are definitely an odd child. I mean, it does not work with any mechanism, and unfortunately, it's something that oftentimes forgotten. When we design anything, we just forget about their existence. And as Don said, it will be much preferred if we can completely get rid of them. But I don't know.
I mean, if we completely get rid of them, that would solve the problems. But I don't know if that's viable. I have been wondering about whether they should be a new resource type, and kind of what some of the implications of that would be, or if there's sort of a more generic way that we can kind of solve all of these exceptions without having to hard code the exception into every single controller and admission controller and everything. But this is maybe a bigger conversation. Just
correct. But that's a good suggestion. Maybe a new kind of object solves part of the problem.
The only counterpoint I'll give to the make all static pods critical is that we do today, at least in GKE, differentiate between some pods on the master and other pods. So we'll mark the API server as critical, but maybe not some GKE add-on that provides a small piece of functionality. So we have had cases in the past where we accidentally run too many static pods on the master, and
that's exactly
it can be random which ones fail. But we have, because we mark only some pods critical and other pods not critical, that means that those pods do get admitted.
I exactly want to point out this is the purpose, try to prevent people abusively using static pods. If people abusively using static pod and put everything on a single node, and which is they are not really depend on the Kubernetes orchestration system, and that's the wrong operation. So that wrong operation we will learn from that production things.
Yeah, I agree. I think that today I think we have enough mechanisms to completely replace the static pods. If you want to target a particular node, you can have like node selector for your pods. If you want to run your nodes on all the you want to run your pods on all nodes, you can still use a daemon set, or even have like a combination of daemon set plus a node selector to run on a set of nodes. So
that doesn't work for self-hosting.
We still have bootstrap type stuff.
Yeah, there are plenty of distributions that use bootstrapping via static pods to even the API server. So those other mechanisms don't work in the bootstrapping case.
Correct. I agree. There are some of these like small number of cases that we can use static pods, but I think for these small number of cases, considering static pods as critical works fine. So, and then for the rest, probably we should try to avoid. I mean, the example that you said is, as Don said, is an example of abusing static pods for solving the problem.
My suggestion would be that we consider, although maybe we should not, but that we consider, even if we get a static pod and the node is already full of static pods, admitting it anyways, simply because that usually means that someone isn't using kubelet resource management at all anyways.
We could do that also.
We have had minor outages because we put too many static pods on the node, and thankfully they've been minor only because we've admitted the really critical stuff. So having just some way of like, even though we're saying this isn't like a great way to run your stuff, having the performance of the system degrade a little bit better when, say, you put too many pods on a node is useful.
Think about the people put the file-based static pod on a single node and manually to say, oh, this one is over higher priority on another one. They already involved with the human scheduling system here. And then we just need them to decide what kind of what it is. So basically, I think this is the abusive things. They basically don't need the Kubernetes orchestration here. Right. So, but I totally understand we cannot deprecate even we are really like because a static pod is really error-prone just by design from day one. But we just cannot get rid of the we should limit it of the real critical use cases, which is the bootstrap of the cluster, and also for the really minimal side of the critical pod required on every node, and so that's I think the static pod is with the highest critical or what is just highest priority number, which is reasonable here.
Yeah, I mean, that's, I think, is reasonable. Another much more inferior solution is to look at the priority class name. So all the critical priority classes or system like critical priority classes start with system. You could potentially rely on that, but it's very, very hacky, and I definitely do not recommend it. It should be the very last resort if you run all the possible other solutions. But yeah, I think considering all of those parts as critical makes sense.
Thanks. Sorry we ran out of time. So next topic, it is to promote the SATCOM to the GA. I personally don't have any against this one. And please.
That's not going to make 116 anyway, so I'm fine. Next week.
And there's another proposal to arbitrary image registry auth in the CRI, and I think that's a good idea. And unfortunately, we don't have the time to talk about this one. I think Nantao, maybe you can carry on.
Yeah, I didn't comment on that.
Yeah. So I already talked to Nantao, and he already commented. So we can carry on through the PR. And the last one, it is a topology, and I think most it is asked for the PR review. I will talk.
Yeah, exactly. So the main point here was just to point out that the current set of PRs are blocked on an owner from Kubelet, not on from the CM container manager sub-project. So we need someone that's in the owner's file for Kubelet to approve some of these so we can push them along.
Sure.
I think what we'd like to do is probably just every meeting for until the 116 release, we might just list the outstanding PRs that need approval from someone outside of our little scope of work, just to see what can be done.
Sure. And there's also people ask for the quota for the ephemeral storage cap update approval. And can you send the PR number and we find? And we design, everything we have the owner, we have like the reviewer and approver. I'm going to find those. Yeah. Oh, that's also Derek. I will talk to Derek.
Okay.
Okay. Sure. I can't. Yeah. Thanks. I will approve that one. Thanks. Thanks everyone, and see you guys next week.
Thanks.